So to summarize, active recall in math is practice testing, right? Practice testing, homeworks, any questions that make your brain think, right? There will be more in modules 3 and 4 on this about how to use practice papers so effectively that they give you the maximum return on investment. In addition, how to save time on your homework while getting the maximum benefit, and also how to study, what to study, when to study, how to use practice papers. Basically, how to use practice papers to get 100%. And I think it's one of the best things you can learn. It's going to help you in math, it's going to help you in your other subjects, and it's going to help you in university. So keep watching. So there's some important things to remember when you're doing practice tests and when you're studying. And we're going to go through them now. So in physiotherapy, we have to meticulously go through these, right? In teaching people how to learn. And so this is what we're going to show you now. All right, so these are the fundamentals which we're going to go over. So practice variables, whole and part task practice. So what is whole task practice? Whole task practice is practicing the whole thing. Let's say you're practicing a penalty shootout, right? The whole task would be running up to the ball and kicking the ball in the back of the net, right? And then part task practice might just be practicing just the run up, right? So how do we apply this to math? This is going to be an activity for you. I want you to think of all the necessary components to lifting a cup of water off the table and drinking it. Now, in physiotherapy, I'm not a qualified physiotherapist yet. I'm in my third year. So, I'm not claiming to be any Einstein, but I thought of 11 steps. And I want to see how many steps you thought of. So have a go at this. Pause the video and we'll come back. Okay, we're back. You better have paused the video. So what are the 11 steps? I got my cup of water here. For me, right, my cup of water's in front of me like this. Move this over here. My cup of water's in front of me like this. First, I have to lift my shoulder up, right, straighten my arm, open my hand, move shoulder and trunk forward to reach the cup. Say it was further out, just can't get it on camera. Right. Close hand around cup, bend elbow, shoulder down to bring the cup closer to you. Tilt your head back slightly, bend elbow, lift shoulder, open mouth, bend wrist towards mouth to drink. So, how many of those did you guys get? I'm curious to know because this really models what we're doing in math, right? So let's have a look at this in depth. Right, whole task and part task, breaking it into smaller parts. This here is an HSC question on trigonometry. Let's say you're struggling with a certain part of this. Let's say you're struggling with the cosine rule, right? I'll just tell you now. Question B is using cosine rule. So let's say you're struggling with question B, cosine rule. To break it down, you're not just going to practice the full trigonometry topic, right? When you're practicing, you might break it down and just practice the cosine rule. Right? And this ties on with our next topic, which is practice specificity. And that's you get better at what you practice. And it's so funny because a lot of people don't realize that if you're struggling with algebra, you should probably start studying algebra. Right? So we got it here, right? If you're struggling with part B, revise part B. How often do we think, oh, I'm good at this, or I'm good at using the sine rule, so I'm just going to keep doing the sine rule because I know how to do it and it makes me feel productive. Right? That's not getting anywhere for you, right? It's not making any effort. You're not laying down any of those train tracks. All you're doing is just reinforcing knowledge that you already know. You're not learning anything from it. So one of the biggest things you can do is to challenge yourself, get uncomfortable, and try and do the questions that you actually struggle with. So that's number 2, practice specificity. Number 3 is practice intensity. Okay, so like I said before, in some of the earlier modules, is that practice, right? When you're trying to rehab from a stroke, doing something like this is so difficult. Lifting your shoulder up is difficult, right? Straightening your shoulder is difficult. And to be able to regain that movement, you have to do thousands and thousands of repetitions. The same applies with mathematics. If you want to get better at math, you've got to do many, right? A lot. You've got to do heaps of questions to get better. We'll go through how we can like shorten this process a bit later. But if you're not doing enough load, like for example, when I went from failing to first in state, I've probably did around 30 past papers leading up to my HSC. Each one of those past papers would have included about at least 30 questions. And some people think that they can get away with doing 15 questions in preparation for their tests, and they think they're sorted. If you do 15 questions, I guarantee you will not get the marks you desire, but you'll get the marks that you have studied for, which is probably not great. Right? Another form of this practice intensity is called the challenge point. And you can observe this graph over here. This is basically saying like, you need to do something that challenges you enough to think, to put that effort in, so you can lay those foundations for the train track, right? How do muscles grow in the gym, right? They grow by you put in an effort, they think, oh damn, this is hard, we need to get better at it. Same with your brain. If you're not doing anything that is challenging enough, then your brain won't think that you need to improve in it or learn it, right? So this graph just says that if you're really, really good at something, so let's say you're an expert in the sine rule, right? You need to be doing questions that are more challenging, right? So you need to be doing questions that are difficult. So this is difficult. This is easy. Right? So you need to be doing questions up here. If you're a beginner at something, so let's say you're not very good at sine rule, you want to be doing questions that are a bit easier, right? That still challenge you, right? But that can help you lay those foundations. So you need to be working around here. Right? Something that challenges you, but still gives you the ability to get it right. Okay, let's move on. This next one is called practice variability. All this is saying is that you need to be doing a variety of questions. We've got here that greater variability equals improved performance in test scores, and less variability leads to decreased performance in test scores. Essentially, this is how textbooks operate, right? And this is why they're so effective as well. If you have a textbook chapter, right, it's going to have one question. The next question is going to be rephrasing of that first question, and it's going to be something slightly different, but using the same concept. If you're not practicing questions that are slightly different or a bit more challenging than the previous question, you're not getting the full advantage of what you could have been getting. Which do you think is more beneficial? To do one question 100 times so you can master it, or do 100 questions, right, one after the other, getting them right, correcting them, checking them, right? Which one do you think is more beneficial? Because in the test, you're not just going to get the exact same question that you studied for. You're going to get a question that is similar to the questions you've studied, but in a different context. So you need to be practicing a variety of questions. In addition, when you're practicing a variety of questions, you'll often be making more mistakes. But let me ask you this, referring to what we've learned before, why might experiencing performance errors during practice contribute positively to skill learning? This next point is so important. this is one of the things that a lot of people just don't realize, right? And it's so useful, right? This is probably one of the biggest steps in the whole process, and that is contextual interference. So, what is contextual interference? Imagine you're playing basketball, or you're training for basketball, and you're training free throws, you're training dribbling, you're training passing. Contextual interference is essentially these. So blocked practice, serial practice, and random practice. Doing blocked practice is just doing one thing over and over again. So in the training session, all you do is just practice shooting free throws. Serial practice is practicing everything in the same order each time. So you do free throws, then you do dribbling, and then you do passing. Random practice is doing them all in a random order. So you might start with passing, then you move to free throws, then you go back to passing, then you go to dribbling, then you go to free throws, and then you go back to dribbling, then you go free throws, and so forth. And what the studies have concluded is that the best type of practice you can do is this thing at the bottom, random practice. What does this look like? I'm a drummer, right? When I'm practicing drums, I used to do like hours and hours of just practicing one beat. And as soon as I started doing this, my whole journey of drumming just changed. It got so much better, so much more quicker. In a practice session, I would choose 3 things I'm going to work on. So that might be a groove, a fill, and then some rudiments, right? Some sticking patterns. I would start by just working on the groove, and then I would move to the rudiments, and then I would move to the fill, right? And then I'll move back to the rudiments, and I'll move to the fill, then I'll move to the groove. And I found that it was so much more effective to practice one thing and then take a break and then go back to that one thing. And I realized I learned so much more, right? It was taking that break and then going back to it was equivalent to maybe an hour of practice. So, 10 minutes, a break, maybe 10, 20-minute break, and going back to it was equivalent to an hour practice. And I was amazed at that. I'm like, this is great. And so I just learned everything so much quicker. And this is backed up by science as well. It's shown that random practice is better than blocked practice. So, for example, practicing sine rule and then going to cosine rule and going to area or something like that, right? And then just mixing them up, right? Mixing them questions, kind of like what practice papers do, is very, very beneficial. All right, why does this work? 2 reasons. First one, the elaboration hypothesis. And this is saying that random practice helps you compare and contrast the different skills, so contrasting sine rule and contrasting cosine rule, and helps you compare and contrast and really differentiate the difference between them both. The second is called the reconstruction hypothesis. And this is saying exactly what we were saying before. So let's go back. There was this basketball coach in the US. It was in this Daniel Coyle book, and he was saying that one of the ways he teaches people is that he gets the players to do a skill just to the point before they fully mastered it. And then he gets them to switch to another skill. This switching is called contextual interference. Something has interfered with you reaching this level here. And when you go back to it, right, you have to learn again. You force yourself to think, how is this done? How do I do this again? Laying down these foundations, right? Laying down these tracks again. You're forcing yourself to think, oh, which way was it? Which way? Did I go this way? No, I went this way. Did I go up here? No, I went straight along here. And this forcing yourself to lay the tracks down is really, really what we're trying to emphasize. The next one is distribution of practice. And this was the difference between mass practice and shorter sessions. So basically mass practice is longer and fewer sessions, and distributed practice is sessions that are shorter and more frequent. If you've ever heard of Pomodoro, I don't remember who told me this, but someone told me that your brain can't learn for more than 25 minutes at a time. And it's kind of, for me, it's really, really true, because after 25 minutes of learning something, right, my brain starts to get foggy and I'm like, oh, I can't practice this anymore. All right. If I take a break after 25 minutes and go into the 5 minutes of rest, right, I'm recharged, and therefore my brain is ready to go again for another 25 minutes. And it is shown that distributed practice, so shorter sessions, but more, are way more effective than just doing a massive, 5 hour or 3 hour block. So how this can look is doing 25 minutes and then a 5 minute break, or even a 10 minute break if you want. And then just doing that, to accommodate for 3 hours of study, or however long you want to study. And last but not least is spaced repetition. And this is using Ebbinghaus's forgetting curve. And I hope I'm saying that name right. But we've all experienced this phenomenon. When you're cramming for a test, right, you put all your effort into that one day, the night before. The test comes, you do the test, you do all right or okay or, bad sometimes. And then the next week, if someone asks you a question about the test, you got absolutely no idea. Why is that? When you first started to learn something here, it was fresh in your mind. Let's say this, for example, is in days. The next day, you're at 40%. So you remember 40% of what you were studying before. The next day, if you don't revise it, remember 30%, right? And 25%, then 10%, 5%, and eventually you've forgotten it, right? These are imaginary numbers. So we need to combat that forgetting curve, because we don't want to forget stuff. So how do we do that? We can combat the forgetting curve by interrupting those points of forgetfulness. So let's say the day after we've learnt something, we learn it again. And then 3 days after, right, we go down again, and then we start to learn it again. So forth. And eventually that forgetting curve starts to get less steep. So it takes more time for you to forget it. And eventually it just becomes so rooted in your mind that it's hard to forget. You don't forget how to read because you do it all the time, right? Your forgetting curve is always interrupted. But how do we apply this to math? And that's one thing that a lot of people don't want to do, but it's so important. Doing your homework. So, some people think that I've revised trigonometry today. That means I have to revise the same thing tomorrow, the same thing next week, and then the same thing in a month, and then the same thing in 3 months. It's just not sustainable. You can't keep that up, and you can't even keep track of that. What you should be doing is doing your homework. Why is that? Textbooks, homework is always built to build up from the last topic. So for example, in trigonometry, you first learn SOHCAHTOA, and then you'll apply it to sides, and then you'll apply it to angles in the next chapter. Each time you learn a new topic, it builds on the last topic you were learning. And so by doing that, you effectively learn the stuff you were learning last week or the stuff you were learning yesterday again, right? It may even be small, but it's still reintroduced, which is what we want to form those train tracks. So in summary, break down question into smaller parts and practice the ones we're struggling with. Then you're going to repeat questions repetitively, right? Do questions that challenge you. Practice multiple types of questions. And this contextual interference is going to form those neural pathways or train tracks, really reinforce that information. Then we're going to have shorter study sessions with more breaks. And then we're also going to get rid of that forgetting curve by doing our homework. So that's a little summary of all this content. I hope you found it useful, and we're going to go into how to apply this in the next video. So I'll see you there.